This video will be about properties of numbers. Now there's quite a few properties that we can talk about. The first one is the commutative property of addition. Basically what it's saying is you can add in any order. So A plus B is the same as B plus A. I think of it as commuting to work. You go from home to work or from work to home. It's the same distance either way. Commutative property of multiplication is similar. You can multiply in any order. A times B is the same as B times A. And I also, commutative, same idea of going to work from work to home is the same as home to work. The associative property of addition is A plus B plus C is the same as A plus B plus C. So you could either do the first two or the last two, and whatever order you choose to do that in, it will still come out as the same thing. I think of associative as who you will associate with, who you're friends with. So I'm associating with A and B, or B and C are associating together instead. So that's how I remember that this is the associative property. Same thing with multiplication. You could do the first two if you add three things, or you could do the last two, and it would come out as the same answer. The identity property of addition, that means what can you add by and it doesn't actually change anything. And the only number that does that is 0. Anything plus 0 stays the same. 5 plus 0 is still 5. 10 plus 0 is still 10. Identity property of multiplication is the same idea, except what could we multiply by? So what could we multiply by so that we get the same answer? And that is 1. Anything times 1 is still the same. The inverse property of addition, for every A, so A is representing a number, there is an additive inverse negative A, such that A plus negative A equals 0. So for every number, there's an opposite. If you had positive 6, the opposite would be negative 6. If you had negative 2, the opposite would be positive 2. Inverse property of multiplication, for every A, again, A is representing a number, where A does not equal 0, there is a multiplicative inverse, such that A times 1 over A equals 1. So again, if you had like 2, if you multiply 2 times 1/2, you get positive 1 as your answer. So there's always a fraction that you can multiply a whole number by to get 1. Next is the symmetric property. If A equals B, then B equals A, so you can flip it, and it still is equal. There's the distributive property. A times parenthesis B plus C, you can distribute that outside number in and multiply it by both things on the inside. A times B plus A times C is the same thing. It also works if you are subtracting. A times B minus A times C is equal to having A times parentheses B minus C. and the multiplication property of 0 for every real number n. N is similar to how we were using a up above. N times 0 equals 0. Anything times 0 always comes out as 0. There's one last property that I didn't put on the list for some reason. Multiplication property of -1 for every real number n n times -1 is -n. If you multiply any number by -1, it'll give you the opposite sign. 2 times -1 would be -2. 8 times -1 would be -8. So what they can have you do is name a property given a situation. Let's say we had 4 parentheses 5 plus 7 equals 20 plus 28. So we think back to our list. We have lots of ones to go through. Now our problem had parentheses. That's a big tip-off. Associative property had parentheses of addition, or associative property of multiplication had parentheses. Inverse property of addition had some parentheses, or inverse property of multiplication, or distributive property had parentheses. So looking at our example again, we have addition, but we don't have a plus sign in between the number and parentheses. That means it can't be the associative property, because associative property would have had a plus sign in between. Or it would be all multiplication. Too far back, sorry. So that gets rid of associative property. That can't be it. We also had inverse property of addition where it equaled 0, or inverse property of multiplication where it equaled 1. That's not the case. Here we have 2 numbers as part of our answer. So it's not either of our inverse properties. We have distributive property where you could multiply the outside number in. So let's check. 4 times 5 and 4 times 7. 4 times 5 is 20. 4 times 7 is 28. So this would be the distributive property. Okay, how about another example? So we have multiplication here. So we'd go look at all our properties that involve multiplication. We have commutative, associative. Now that had parentheses, so we can ignore that one. We had associative or identity property of multiplication. Inverse property of multiplication, that involved fractions. We don't have a fraction. Multiplication property of 0, so we had 0, we had -1, or we had +1 for our identity property of multiplication. None of those are part of our problem here. We don't have 0, 1, or -1. So only multiplication property left was associative property of multiplication. Now they can take it one step further and have us go through a process where we simplify something and justify each step. So a lot of these steps, when you get used to them, you just kind of do in your head. You don't write out, oh, I'm doing the associative property of addition. But that's what they want us to do here, is go through and figure out what properties are we really using that we don't always think about. So first, we would want like terms grouped together, so I'm going to move some stuff around. And we talked about moving things and said, well, that's commutative. When we're commuting somewhere, we're moving physically from one location to the other. So we used the commutative property of addition here. Commutative, I'm not going to write the whole thing, of addition. We moved it around. Then we want to actually add the things with the same letters together. So I want to add these two things together, which would be the associative property. We're adding the first two together first. So associative property of addition again, because we're still just doing addition. Now if I want to add them together, they each need a number. So in front of A, we can write a 1 because of the identity property of multiplication. And I should have maybe written this in a few extra steps. I'm going to say 5 plus A plus 6. So the parentheses should have been on the second line. So now I can write this out a little bit better. Plus 1A plus 6. It's the identity property of multiplication. This is 1 times A. So now that there is a number in front, I can get to a place where I can add these together. When we add these together, what we're really doing is kind of backwards distribution. I'm going to take out the A and have just the 5 plus 1. So we did distributive property backwards, which is okay. Even if you go backwards from the right side to the left, it's still the distributive property. And now I can add these together. 5 plus 1 is 6. But we usually put the number in front of the letter, so 6A plus 6. That step we just actually did some addition. We didn't use one of the properties, we did an actual math operation. So most of the time when you go through a process, you're not going to go through each of these steps. You're going to say, oh, I have these like terms, 5A plus 1A is 6A, and I just bring the 6 down. But it's good to know what properties did I use when I went through that process. What was I really kind of assuming had happened? And these are kind of all these things we do in our head without even realizing it. So that concludes our discussion on the properties of numbers.